Okay, so today we're looking at how to factor a simple trinomial. And remember, a trinomial is an expression that has three terms in it. So it's usually going to be an x squared term, an x term, and a constant, but not necessarily. If you haven't already done the mini investigation on this first page, please stop the video right now and do it, because I want you to simplify those four expressions and try to make a connection between this factored form and the standard form. So this is what you should have had for part B. Okay, so on the left, we have the factored form of the equation with our m and n values. And then on the right, we have our simplified expression, so our starting equation. And then these are the b and c values from the standard form. The connection you should have made was that m plus n gives us that middle value. So 3 plus 2 gives me this 5 right here. Negative 4 plus negative 1 gives me this negative 5 in here. For the constant at the very end, we should have seen that the numbers in the brackets, if we multiplied them, we get that constant. So 3 times 2 gives me 6. Negative 4 times negative 1 gives me positive 4. Now we're going to use this connection to factor our expressions. So if I were to start with this equation here, if I can find two numbers that add up to 5 and multiply to 6, I would get these m and n values, which I can then just place in my brackets. So in the previous unit, we were given a factored equation, so something like this, and we FOILed to get it into standard form. Now we're going to do the opposite of that process, and we're going to start with our standard form and get it into factored form, and that's trinomial factoring. Now, the process for a simple trinomial. Now, a simple trinomial is when that x squared term has a coefficient of 1. So that's what it says right here. So standard form when a equals 1. There's a quick shortcut that we can use. So if I find two numbers that add up to my b term and multiply to my c, I can factor. So I'm just going to zoom in and write that in. So m plus n gives me the middle term. M times n gives me the constant term. Okay, so let's try a little example here. We're going to factor x squared plus x minus 6. Now we need two numbers that give us a product of negative 6, so that constant at the end, and a sum of 1. Now we have to think of some possible answers. Now this is the long way. What are some possible answers that give us a product of negative 6? Well, I can have negative 6 times 1, negative 3 times 2, or I can have positive 3 times negative 2, or I can have positive 6 times negative 1. Now those are my options. Now from these options, I'm going to cut a few off because I want to see which pairs also add up to 1. Negative 6 plus 1, well, that's negative 5. That's out. Negative 3 plus 2, that's negative 1. That's not what I want. 3 plus negative 2, that's my winner. 3 plus negative 2 is 1, and that's that coefficient of x. So now, once I have my two magic numbers, I'm just going to put them in brackets. So here's how you're going to set it up. You're going to open up two brackets. Each one's going to start with an x, and then you just put those magic numbers in. If it's positive, you use addition. If it's negative, you use subtraction. So if my numbers were positive 3 and negative 2, I'm going to have x plus 3 and x minus 2. And that would be my factor expression. Now, if you want to check your work, you can always FOIL this factored expression to see if you get the standard form that you started with. Okay, let's try a few more. So this is how I'm going to set it up. I need two numbers that multiply to the constant. So they have to multiply to 27, and they have to add up to my middle, and that's going to be 12. Now I have to think of some options. So for 27, I have 9 times 3. 9 times 3 is 27. 9 plus 3 is 12. That's perfect. I found my magic numbers right away. Once I have those magic numbers, I can set up my brackets. So x plus 9, x plus 3. Just taking those magic numbers, putting them into the brackets. Now this is a little bit of an easier example because both the product and the sum have to be positive. If we look at the next example, we need a product of negative 12, and that just means one of our numbers has to be negative, and the sum, remember if you don't see the coefficient, it's just going to be positive 1. Now if my sum is positive 1, that means the larger number should be positive, and then the smaller one is going to be negative. Now I start off by thinking, okay, what gives me a product of 12? Well, 4 times 3. If I make the 3 negative, 4 plus negative 3, that gives me a sum of 1. So that's perfect. So 4 times negative 3, 4 plus negative 3. And that works out. And this is what I was saying the other day. You need to know your multiplication table to make this quicker. If it takes you a long time to think of two numbers that multiply to a certain number, you're going to be there for a long time. And using your calculator, yeah, it's going to help you, but it's going to make things go a lot slower. So now that I have my magic numbers, I set up my brackets. X plus 4, and because my 3 is negative, I'm going to have x minus 3. Okay, I want you to pause the video right here and try B and D on your own, and then we'll take it up. Okay, so if we look at B, we were looking for two numbers that multiply to positive 12 and add up to negative 8. Now, whenever your two numbers have to have a product that is positive, your numbers can both be positive or both be negative. The fact that we have a negative sum means both the numbers have to be negative because negative times negative is positive. So your answers in these cases, your magic numbers, should have been negative 6 and negative 2 because they multiply to 12 and add up to negative 8. So your factored form would be x minus 6, x minus 12. For question D, it says you need two numbers that multiply to negative 10, so one number has to be negative, and the sum has to be negative 3. Because the sum is negative, the larger number should be the negative one. So in this case, we have negative 5 and positive 2. So x minus 5 and x plus 2. Let's go to question E. Now this might not look like a simple trinomial because we have that 3 in front of the x squared. Your first step for any question should be check for a common factor. In this case, if I look at my coefficients, 3, negative 18, and 27, all of them have a greatest common factor of 3. Now they don't all share an x, so I can't factor out the x. So I'm going to common factor out a 3 so that my equation is going to look like 3 times x squared, because 3x squared divided by 3 is x squared, negative 18x divided by 3 is negative 6x, and then 27 divided by 3 is 9. Okay, and now we can do our simple trinomial calculation. What two numbers multiply to 9 and add up to negative 6? Now you don't have to do the side note that I do. You can write it out like this. Product is negative 9, sum is negative 6, and then think of your numbers that way. But in this case, our two numbers are going to be, the product has to be positive, which means both of your numbers are either positive or both of them are negative. Because my sum is negative, my two numbers are both going to be negative. Negative 3 times negative 3 is 9, and negative 3 plus negative 3 is negative 6. So our final factored equation is 3 times x minus 3 times x minus 3. Now because our brackets are the same, we can also write this as x minus 3 squared. Either one works. Pause the video right here and try F on your own. Look for that common factor first, like we just did. Okay, so we should have common factored out a 2, so that we have 2 times x squared plus 5x plus 6, and then you were looking for two numbers that have a product of 6 and a sum of 5, and those two numbers were 3 and 2. 3 times 2 is 6, 3 plus 2 is 5. So here's your final factored equation. 2 times x plus 3, x plus 2. And that's it for simple trinomials. Find two numbers, those two magic numbers that multiply to the constant, add up to the middle, and just check for a common factor first to get that simple trinomial.